Hi, I'm James Mallows. I'd like to show you an idea I've been working on. This is what I call a twong. It's a helical piece of wire that's been bent in 4 places. Maybe you can see where it's been bent. Here and here, the other end, here and here. The helical shape comes from taking 2 wires and twisting them up together and then unraveling them, so you get 2 wires from one twisting. These go together 3 by 3 into a join like this. I call that a vertex. I'll show you how they go together. Twongs have 2 sides. They have one side that looks like an S and one side that looks like a Z. When you're putting them together, you always have to work from the same side. So I always look for the Z side. You're going to use the 2 bends, which define a side of the triangle. Each twong contributes one side. So here's the next twong. It's also got 2 bends. So we're going to bring these together, and they'll become one vertex of our triangle. They could go a couple of ways, but only one of them works. You'll find that they start to twine together like that. That's about as far as I can take them by hand, but I use a wrench. So it's a piece of aluminum with a slot down the middle, so that I can exert more force. And it's a little hard the first 2 because there's not much to hold on to. But there we go. We've got 2 together. You can start to see where the last one has to go with its 2 bends. Taking another piece from the Z side, finding its 2 bends. Now they go together like weaving, so that what goes over has to go under next. So when we find this piece, for example, goes over, so it's going to have to go under the next one, and likewise with the other side. So this piece is going to fit in like that, and there's only a few possibilities. As a beginner like me, you just try. Ready for the wrench. A little smaller scale, you can just use your fingers, but with this 9-gauge wire, it's pretty heavy. So it's just one, we're almost there, one more bit of twisting here. And this is reversible. You take these apart and put them back together. There you go. What have we got? We've got a 3-way join. Not much by itself, but there's a lot of shapes we can make that have nothing but 3-way joins, and we can make all of those with twongs. I'll show you some examples. The simplest shape is a tetrahedron. That is 6 twongs with 4 vertices. A few steps up, we're using 12 twongs to make a cube, which has 8 vertices. But that's not the only shape we can make with 12 twongs. As it happens, we can also make this shape, which I call tweak, T-U-I-C, the unique isomer of the cube. It's a pretty unusual thing. So at this level of 12 twongs, we can make 2 shapes, but it goes up in a combinatorial explosion. By the time we get up to a dodecahedron, which uses 30 twongs, there are about 14,000 shapes we could make. By the time you get to a buckyball, which would use 90 twongs, there's like 10 to the 22nd shapes. This is just an incredible variety of shapes. No one has ever made the models for them, but you could make them with twongs. It's all very simple. There's one amazing thing, though. Let me tell you about that. So there are trillions and trillions of shapes we can make with twongs. Do we need blueprints? Do we need drawings? Do we need notations to make those? Do we even need to know where we are in the building process when we're making it to make all those shapes? Amazingly, we don't. All we need is a 4-letter code. It's reminiscent of DNA. 4 letters, a simple sequence of letters. We follow it mindlessly, letter by letter, and it builds a shape. I'm not going to explain the whole details of it, but you read these letters as if they were emoticons. When you look at a smiley, you tilt your head to the left. When you look at these, you need to tilt your head to the right. I'll make it easier for you to turn it up like this. Now we're just reading from the bottom up. No need to tilt. The 4 commands for weaving are open left, open right, close left, close right, And I think if you look at these letters in this direction, it's not hard to figure out which one is open left, open right, close left, close right. This sequence, starting from the bottom going to the top, is the sequence for tweak. It's for this guy. There are many other sequences that also code tweak. This one, again, reading it like this, is a sequence for a cube. If you wanted to build one of those 10 to the 22nd isomers of the buckyball, it would simply be a 20-letter sequence that you need to follow. You don't need to know where you are, you just follow the code. Pretty amazing. If you want to know more, I hope to be having a table at the Maker Faire New York, at the New York Hall of Science on September 25th and 26th of 2010. Hope you can be there. If not, check out my website at weaveanything.blogspot.com. Thanks.